this is dt. And then we're going to power up so that this will change to the position formula. And then we power up, so plus 1. So it's going to be 3t3 over the exponent subtracted by 12t plus 1, which is going to be squared over 2. And then this dt turns into plus c. And then from here it says that when the particle is at the position is going to be -4. So then this turns into -4. And then we're going to plug in t, which is 0. So when we plug in here, it's just going to be 0 minus 0 and then plus c. So we have that c equals -4. And then we'll use this to plug it back into the equation that we're looking for. So the position is going to be reducing this t3 minus 6t squared, plug in this c, which is -4. So this is the position of the particle. Then for part B of this question, it says, in which direction does the particle begin moving and when does it turn around? So to know this, we're going to set the velocity equation to 0. So 0 equals 3t squared minus 12t, because when it turns around, that's when it's going to stop and then move. So we have to use 0 for this, and then we'll break this down into 0. We can split this and take out a 3t, so we'll just have t minus 4. And then we can reduce this. We take 3t equals 0 and then t minus 4 equals 0. So then t equals 0 and t also equals 4. So then to decide in which direction does the particle begin moving and when does it turn around, we use this, and then we'll see when velocity, between these, we'll choose a number between these to see when velocity was negative and when it was positive, so when it was moving left and when it was moving right. So we can choose 1 from here and then 5, and we plug these back into the velocity equation. So if t equals 1, 3, 1 squared minus 12, 1, which is 3 minus 12, so we know that this one's going to be negative. And then for this one we use 5, 3, 5 squared minus 12, 5 is 3, 5 minus is 60, and then this is 75 minus 60, so we know this one's going to be positive. So then we know from 0 to 4, the particle begins moving left, and then from 4 to infinity, since it's positive, the particle moves right, and then it changes direction at t equals 4. And then to find the distance traveled in 6 seconds, we know from part B that it changes direction at t equals 4. So for this part, we're going to break it up into integrals using the velocity formula, and we're going to get going from 0 to 4, which is the first part, 3t squared minus 12t, and then we'll add that to the rest of it so that we have a total of 6 seconds. So from 4 to 6, and then the same, 3t squared minus 12t. And then from here we power up so that we get 3t3 over 3 minus 12t squared over 2. plus 6, 4, and then this is the same thing. And then when we reduce, we get 4, 0, t3 minus 6t squared. Oh, and this is going to be, this is after you power it up. So this becomes, on this side, from 4 to 0. And then you're still adding, this is the same as this, so you get t3 minus 6, 2, but from 6 to 4. And then from here you plug in the 4, and then you subtract like into the whole equation, so you get 4 to the third minus 6, 4 squared, and then this is subtracted by plugging in 0, which is 0 minus 0, so it's just 0. Plus, then for this, you plug in the 6, which is 6, 3 minus 6, 6 squared, 6 squared, subtracted by plugging in 4, which is the same as this one. So we'll just leave it there until I calculate that one. Then from here, and then for this one we get negative 32 here, which is when you plug in 4, so it's the same as when you plug in 4 for here, and then we get 0 here. So then we'll have negative 32 plus negative 32, but since we're calculating the distance, we'll do absolute value. So then we get positive 32 plus positive 32, which equals 64. Then for this problem, we have to evaluate this integral. So for this one, we're going to use u substitution. So when we have this, u is always going to be like what's under the square root sign. So u equals 2 minus x. So then du is just negative, it'll be negative 1 dx. So then from here, we have to find this, and since we'll just add in a negative, and then since we add it here, we'll have to add it over here as well. So then we'll have negative 2, 1, x plus 1, u 1/2, which is the same as square root over u. And then this will become du. And then for this, we can, since we still have this x here, we can solve for x here, which will give us 2 minus u, and then we can plug in this x for this. So we'll have negative 2 to 1, 2 minus u plus 1, u 1/2 du. And then we solve down from here and we get 3 minus u, u 1/2 du, 2, 1 negative. And then we can distribute this u in so that we get 2, 1, 3u 1/2 subtracted by, and then this is u1 plus the 1/2, so we have u 3 over 2 du. And then from here we'll do the antiderivative, so we'll power up. This becomes, powering up, we'll have 3 times u to 3/2 over 3/2 subtracted by u powering up is u 5/2 over 5/2. This, we can take this negative and distribute it. So then we'll get negative 3, and then this is the same as u 3 over 2 times 2 over 3, and then this becomes a plus because of the negative, u 5 over 2 times 2 over 5, And then this cancels out, so then we have negative 2u 3/2 plus 2u to the 5 over 2 power over 5. And then from here, we can plug in what we have for u. So then we have negative 2 minus x, 3 over 2 plus 2 minus x, 5 over 2 all over 5, and then this is 2 over 1, or 2, 1. And then we'll just start plugging in. So we get negative 2, first we'll plug in the 2 minus 2 to the 3 halves power plus 2 minus 2 all over 5, and this is to the 5 halves power, and then this is all subtracted by plugging in 1, which gives us negative 2, then 2 minus 1, which is just 1, and to the 3 halves power plus 2 over 5, this is 2 minus 1, which is just 1, to the 5 halves power. And then from here, we'll plug in, this is 0 plus this is 0 as well. So then this part gives us just 0 minus negative, this will just be 1, so we'll just get negative 2 plus 2/5. So then this negative is distributed, so we can change this to 10 over 5. This will be positive minus 2 over 5 equals a positive 8 over 5. And then that's our answer for this equation.